Since this section does not include a lot of notes, I do want to just go over it in the video at the same time as I go over the practice problems. Let me go ahead and zoom in a little bit here. We're talking about section 3.1. In 3.1, we're working with frequency tables. You've probably seen these before in various classes with various different types of data. But if we're talking about a frequency table, what we're doing is we're showing the frequency or the number that each response occurs. And this can happen with two different types of data. So just like we've talked about before, we can see it with the qualitative data and we can see it with the quantitative. So remember, qualitative data is going to be a specific category, whereas quantitative has a number value. Let's talk about qualitative first. Qualitative, we want to show the response or what the category could be. So I put it in parentheses here because we don't necessarily want to keep it that way. We're going to want to label it with whatever variable it is that we're measuring here. So if we're talking about maybe favorite color or type of pet, we would put that as our column title. We then, next to it, want to count the frequency or the number of times that each response occurs. So we're going to have an actual numerical value there, 7, 13, anything like that. To get the frequency, people may do tallies, and that's okay, but just make sure that in our final frequency table, we do not keep tallies in this column. We end up having a number like 5 or 13, etc. In frequency tables, you will also see two different types of frequency, one called the relative frequency and one called the cumulative frequency. When we're talking about relative frequency, we want to know what is the frequency of that category compared to the total frequency. And I'll work more with that in the first example. And then cumulative, what we're doing is we're saying, okay, well now let's count all of our frequencies as we go along. So I'm going to go ahead and clear this. And then talk about quantitative data. So when we're talking about quantitative, these three columns are going to be the same process as we did with the qualitative data. The only thing that's going to be different is now we're going to have binned data. So let me throw an example over here. For an example, it's going to be a range of data. So we could say if we're talking ages, for example, maybe ages 6 to 10. And notice here that we do not have 4 possible values. We actually have the age of 6, the age of 7, the age of 8, age of 9, and age of 10. So there's 5 different values. And we would say that that is our width, or our bin size is 5. Our next one would then start at 11, and we would have 11, 12, 13, 14, 15, and so on, so on, so on. Notice we could also find the width by looking at where our ranges or our bins start and where they end. They should have a difference. So notice we have 11 minus 6, which gives us that width of 5, and 15 minus 10, which gives us a width of 5. So do not think that we can just subtract the values to find that range. Let's jump right in to looking at some examples. This is the best way, in my opinion, to illustrate frequency tables is by actually looking at them versus just talking about them. So if we're looking at this frequency table, we were given just the first 2 columns of data, and we're talking about the number of children in American families. It wants us to first complete the table. So to complete the table, we have to, in order to calculate relative frequency, we have to figure out what our total frequency is. So if we're looking at our total frequency, we would have to add up the frequency or number of families in millions. So we can see, as we did in B, we can see that we should have 70.24 million. So all I did is I added all of these up and I got our total frequency. Now, in order to find relative frequency, we want to take the frequency that is in the corresponding row. So we have 35.54. We want to divide that by that total frequency, that's 70.24. Most of the time you'll see relative frequency in terms of a percentage, especially here if we have decimals. Having decimals in the fraction just doesn't look very nice. So we're going to want to change that to a percent by multiplying by 100%. Let me clear this. So for relative frequency, we're going to do that for each of these values. So to get this 20.4%, we're taking this 14.32, dividing it by that 70.24. And multiplying by 100. Once we get to cumulative frequency, what we want to do is we want to add up all of the frequencies that have happened thus far. So here we notice in this first row, the only frequency that we've seen is at 50.6. So that is our cumulative frequency here. To get the cumulative for the number of children to be 1, we're going to take that 50.6 and we're going to add it to the 20.4. And as we move down, notice now we're taking this 71, and we're going to add that 18.9. To keep going, we have 89.9 plus 7.3 to get that 97.2. And then 97.2 plus 2.8 to get that 100. So we're taking the frequency in that row plus all the frequencies before it. It then asks how many families have 2 or fewer children. So that means that they can have 2, 1, or 0. So we want to add up the number for each of those number of children. So we have 2, 1, and 0. We add that up for 63.14 million. Here it says for D, what percentage of American families have no children? So notice we could work it out again, right? We could take this number of families divided by the total number of families and multiply by 100, or we can just take that relative frequency for that row. For E, it says what percentage of American families have 3 or more? So we're looking for 3 plus 4 or more. So that's where this 7.10 is coming from. Then dividing it by that 70.24, which again was our total, and multiplying by 100. So we came out with 10.1%. Another way we could have done that is we could have said, well, let's add the relative frequencies. So for 3 children, we have 7.3. And for 4 or more, we have 2.8. Notice we end up with that same 10.1%. Go ahead and go to the next page here. We are given body temperatures in degrees Fahrenheit of randomly selected subjects who were not sick at the time. We want to construct a bin frequency distribution starting at 96.9 and using bin size of 0.4 of a degree. Notice I mention it here in writing. I want to also say it out loud to you. But I will always give you the first bin and the bin size. You will then be asked to construct it from there, but you will not have to figure out your own bin widths. So in the book, I think they talk about how to do that. That's a little bit outside of the realm, I don't know why I said that weird. A little bit outside of the realm for this class. So I will always give you this first bin in the bin size. Notice what we're doing here then whenever we set up our bin frequency distribution is we're starting with that 96.9 and we're adding 0.4 degrees. So it's going to go up all the way to 97.2 because we could have 96.9, 97.0, 97.1, and 97.2. So that's going to be our bin size of 0.4. So it ends at 97.2. Where one ends, our next one starts at 1 unit higher. So if we're talking bin size in tenths of a degree, then it will be 1/10 of a degree higher. If we're talking by ages of 10, then it would be the next one up. So notice here, 96.9 to 97.3, we have a bin width of 0.4, and the same over here as well. So once we have that organized, we want to just make sure we have our highest value accounted for, and then we can go ahead and go through and find our frequencies. So to do that, what I did is I'm saying, okay, 98.6, that would be in this row. So I first went ahead and made a tally, and then I went through and added all of our frequencies to make sure that I had the total number that's mentioned or the total number that's accounted for in our data set. It then goes on to say, provide at least 2 details gathered from the table. I went ahead and just added 2 possible interpretations off to the side. Just know that what you took from this table could be slightly different. So I have, we could say that the most common temperature range is this range, and we can determine that from our highest frequency. We can also say that the least common temperature range is 98.9 to 99.2, and again, pulling that from our table. So as long as your interpretation here makes sense, you do have creative freedom on your interpretation. Let's look down at 3. So here, we're looking at a local high school, and we're recording the age and the mode of transportation for that student. And we have that data listed. Because in order to be analyzed or displayed, the data must be binned with respect to both variables. So we need to have it organized where we can see age and transportation. The main reason why I brought this up here is because we will work a lot with two-way tables as we move on in this class. So I wanted to make sure that we could see it here. Notice if we're looking at the table, the way that I constructed it is I have one variable at the top. This is the transportation that they took. And then I have one variable on the side. So here I have the age of the student. And we can see the possible options for transportation and the possible ages. To fill that table out then, I then went back up. I'm going to scroll up, but it's going to keep my writing, but I just want to show really quickly. I went up and I said, okay, well, for example, this student, this first one, who is 14 and walked to school, would then go in this square right here. And there's different questions that I could ask from this. So to clear and scroll down, Notice a possible question here is how many 16-year-olds drove to school? So we can see that we have to first look at the age of the student. And then like Battleship here, right? We have 16 and we're looking for how many of them drove and where does that meet? So it meets right here. And we can say that only one student did both of those. So a way to look at that would be and 16 and drove. The second possible one says how many students were 14 or 17 years old. So notice here I can see how many students were 14 by going all the way across. So we have 5 students that were 14 and I have 2 students total that were 17. We get a total of 7. And how many students walked? Well, now I'm just going vertically. So looking at walked, I have 1, 2, 3, 4, 5. And we do work more with two-way tables as we go on. So I'm going to go ahead and end this video. And then the next one, we'll be talking about the last 3 sections in chapter 3. So we're going to talk more about picturing data. I'm going to do it the same way where I just kind of show the practice problems at the same time with the completed notes, just since it is more wordy.